A particular fruit's weights are normally distributed with a mean of 766 grams and a standard deviation of 36 grams. The heaviest 12% of fruits weigh more than how many grams? In this situation, the first thing that I notice is that we're told that we have data that is normally distributed. In that kind of a situation, the first thing that I recommend doing is sketch a bell-shaped curve and put the pertinent information on there. So we have an overall mean of 766 grams with a standard deviation of 36 grams. Now the mean is 766, and that's a number of grams, so my axis here is labeled in grams. Now the question says the heaviest 12% of fruits weigh more than how many grams? It's not asking for a probability or a percentage. So what I'm looking for is an answer in terms of grams, which is an answer along the x-axis. And this is more than how many grams, and we're saying the heaviest 12%. These are all indicators that when we shade this region, I'm going to be shading the area under the curve as the upper 12%. And the answer that I'm looking for is this value x, which is a number of grams. So I'm not using normal CDF, I'm going to be using inverse norm. So writing all this information on a chart will help you organize and figure out which function to use in the calculator. Now, inverse norm takes three inputs. It takes an area to the left, it takes a mean and a standard deviation. You don't always have to provide the last two, but in cases where you have been given a mean and standard deviation, you absolutely should. But the output of this will be the value of x, the missing value that we're looking for. Now, the one thing you have to pay attention to when it comes to inverse norm is first input is the area under the curve, but it has to be an area to the left. That's the only way the function works. And so if I have shaded the upper 12%, that's an area to the right. What I have to do then is convert that area from the right into an area to the left, which is easy to do. You just take 1 minus 0.12, which is equivalent to 100 minus 12 for percentages, and that's going to give 0.88. So the area to the left is going to be 0.88. That's what we'll provide to the function. Now, the mean and standard deviation, those we don't have to make any adjustments to. We just give them as is. Now, when I use my calculator, go to the distributions menu, so hit second and vars. The third option down for me is inverse norm, and I give it three inputs, 0.88, separated by commas here, of course, then 766 and 36. So that gives me a value of 808.2995. Then you just have to follow the rounding rules for the particular problem that you're working. Generally, the recommended rounding rule is to round to the same accuracy as the original mean and standard deviation. And since those are both to the nearest integer, 808 is probably a perfectly acceptable answer in this case. But follow any rounding rules that are given in the problem. Now, some of you, when you went to inverse norm, you may have seen a menu, and that's okay. It's a feature of the later model calculators, and it's trying to help you remember what the inputs to the different functions are so that you don't have to remember which ones are which. All right, for inverse norm, it takes area to the left, mean, and standard deviation. So you just type those in at this point. So it does still have to be an area to the left, and give the mean and then the standard deviation. There's no commas here because when you hit paste, it's going to take those numbers, put commas between them, and then feed them into inverse norm in the correct order and give you the same answer in the end. So whether you see those menus or you don't, it doesn't make a whole lot of difference.